Hello, this video is going to be on polynomial functions, and that kind of is a broad term. So this one's going to be on what is turning points, end behavior, and just a couple notes on the differences when you're subtracting different patterns. And that's kind of what this video is going to cover. It's 5.1 in the Algebra 2 book. Try to make that focused a little better. Okay, so let's start with what is a turning point. So let's think about some kind of a graph of maybe a quadratic or any kind of graph that you could think of. A turning point is when I start to go from one direction to the next. So a turning point would be right here, the vertex of a quadratic. And so that's what the turning point is. You could also have something that has more than one turning point. It could have, 1, 2, 3 turning points. It could have no turning points. So that's kind of the idea of a turning point. The maximum number of turning points is the degree of a polynomial minus 1. Of the polynomial minus 1. My minus doesn't look like an I, minus 1. So if you have a degree of 2, the most turning points you're going to have is 1. If you have a degree of 6, the most turning points you're going to have is 5. The most. So you could have less. So it depends on the graph, but that is the most turning or the maximum turning points. So like for example, if I have y equals x to the third plus 2x squared minus 3x minus 1. So here's my polynomial. So this is in standard form, so the highest exponent is a 3. And so the degree of this polynomial is 3. So the turning point, so the degree is 3. And then the turning points would be the maximum is going to be 2. Right? Because there's 3 degrees, 3, 1 less is 2. So that's kind of the idea of the turning points. You can also graph this on a graphing calculator, and that'll give you a good, where you can actually see the turning points. Let's look at end behavior. Okay, so end behavior is the direction on the far left and the direction on the far right of your graph. Like, what is it doing? Is it going up or is it going down? Is it decreasing, increasing? That's kind of what we're talking about when we say end behavior. So it is the direction of the graph at the far left and far right. Okay, so end behavior, far left, far right. What does it do? Well, let's just look at a graph of something and I'll show you what that looks like. So if I have a quadratic that looks like this, what is the far left doing? It's going up or increasing, and the far right is going up or increasing. So the way that we would state this end behavior is it's up and up. That's how this book does it. Up on the left, up on the right. So you always do your left side first. But let's do the general rules for that. So we look at the leading term. And what the leading term is just the term that has the degree, the one with the highest exponent. That's your leading term. And it's usually in the form of like a some number times x to some power. Okay, so maybe it's 2x to the fourth. Maybe it's negative 5x to the seventh. So that's your leading term. And what this tells us is if a is positive, then we also have a couple other things here. And the n is even n, or odd n. So even is like our parabola. It kind of gives the same shape. So anything that's even kind of has this shape here. It could go like this, and then up. or it could be down and then go wiggle, wiggle, and then back down. But even ends, they're the same. So if you're positive and you're even, then your end behavior is up and up. Okay, so they're both up and up. So if the A is negative, okay, hold on, let me pause. Okay, so then if A is negative, then that means down and down for your end behavior. Now, odd is different. So odd, they're opposite. Like if you think about x to the third, they kind of go up and like this. So if it's positive A and it's odd, then it's going to go down and then up. If it's negative, it's going to be opposite. So it'll be up and then down. So that's the rules. And that's all you have to look at is basically that leading term, if it's positive or negative, and if it's even or odd. And you kind of look at it from there. Let's do an example of one that kind of, we talk about the end behavior. So what if we have y equals x to the third plus, let's do negative x to the third plus 2x squared minus x minus 2. So here's this, and you're asked, what is the end behavior? All right, so we look, make sure it's in standard form. It is. It goes x to the third, x squared, x1. So the leading term is negative x to the third, and it is negative. So that's going to put us in this category here. And then the power, the degree, is odd. So we're here, up and down. And I wanted to show this on the calculator to show you what it kind of looks like. So hit the y equals on the calculator, and I'd have negative x to the third plus 2x squared minus x minus 2 graph. And you can see that it's up and then down. Up and down. That's what we put. You could use the calculator online too, either way, and you could get the end behavior and double check it on the calculator. Okay, so what about y equals 10 x to the sixth minus 3x squared? Okay, first of all, it's in standard form. It goes 6 and then a 2, so it's going down. So our leading coefficient or leading term is here. Leading coefficient is 10, and that's positive. And then it's even because it's a 6, so we're positive and we're even. So this one's up and up. And again, you could graph it on something and double check. And that's all end behavior is. So you're just looking at that first term. Another thing that we're talking about is those turning points. We know that there's a maximum number of turning points. So let's look at, they like doing a lot of the x to the thirds in this section. So if I have like y equals 1/3 x to the third, and if I look at this one, how many turning points does it have? Well, it could, the max it could have is 2, or it could have none. So, or 1, no, it'd have 2 or 0. So let's graph this. So to clear out what I have, and I'm going to do 1/3, so 1 divided by 3, x to the third, and that was the whole graph, so I'll graph that. And it kind of looks like it has a turning point, but it doesn't. It's always increasing, 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 increasing. It kind of goes a little whoop and stays here a little long, but it doesn't go like down and then up. So one that would probably be, let me do third minus 5x to the second, something like this. Something that has more turning points is something like this one. I graphed them both. This one doesn't have much, but see how this one goes up? And it totally turns the other way and then goes back up. So you can see that the second one that I graphed definitely has 2 turning points, whereas this one does not. So this one has no turning points. So you just have to look at the graph to kind of decide. And what if I have this one I think this is close to what I just graphed, but it's a little bit different. What if I have negative x to the third plus 3x? What are those specific turning points? So I can get those on this calculator or the calculator online. So I'm going to show those real quick on here. I'm going to put in my equation again in y equals, so negative here, x to the, negative x to the third plus 3x, and then I'm going to hit graph, and we can see the two turning points, but we want to know where they are. On this calculator, and this kind of does the same thing in section 5.2, it's called a minimum, a relative minimum, a maximum, so you do it the same way. I want to find, if I go secondhand calculate, I want to find the minimum or maximum. So this one's a minimum here, and then you have to make sure you're on the left. It says left bound here. Here's the minimum that I want to find, that turning point. I have to be on the left side with my blinky, and then I click enter, and then I have to move him to the right side, but you can't go too far because you don't want to get over the other point there, and I hit enter, and I don't know why there's a guess in there. It's not really the answer. You have to hit enter again. Here's the answer, -1, -2. So we have one turning point at -1, -2. Okay, and then let's go do the maximum this time, because this one's up high and I have to be left of the maximum. So I hit enter, and then I have to go to the right of the maximum, hit enter again, pass that guess because I really want to know. 0.999999 is like 1. Oops. So 1, 2 is the other point. 1, 2. So it gives us, it kind of rounds a little bit, but you can get the idea from that calculator. 1, 2. So if you use the graphing calculator that looks like this, if you put in negative x to the third power, what did I have? Plus 3x. Graph this. The way that you do it in this one, again, I'm looking for this point, is you push trace, and here's where he starts at 0, 0, and I just move him over to here, as close as I can get. And the point is listed here. So it doesn't do exact, well, it did on that one, -1, -2, there's that point. And then if I move up, I'm trying to get exact 1, 2. It did do it exact. There's how you do it though, trace on this one. So you can do it the same way with that graphing calculator as the other one as well. Okay, so then that's how we find our exact turning points. And you could decide about increasing and decreasing. So the book talks about this a little more. These are our turning points. And we want to know, like, what does it do in between? So if I look at the graph, I can see here's our turning point. It is doing what up to that turning point? It's decreasing, then it's increasing, and then it's decreasing. So you could see where it's increasing and where it's decreasing. I have to kind of hold it at a weird angle to see this, but you might be asked some questions about that. So you have to be able to look at the graph and decide when it's increasing and decreasing. One last thing I wanted to make sure you realize is when you have like a group of numbers like x's and y's, and remember you look at, like, there are a bunch of points that they give you, you can look at those differences. To get an x to the third, it's those third differences that would be the same in order to find something that's a cubic. So in the book they give an example here. Zoom in for a sec here. Okay, and they say, okay, here's our y values, and then they subtracted them, got a weird pattern, no real pattern there, and another pattern, and then they subtracted them a third time and they got the same number, -6. So the third, these are constants. That means it's going to be a degree of 3. So just remember that if the first differences are the same, you're going to have linear, and if the third differences are the same, then you're going to have a cubic, or power of 3, degree of 3, and there's other rules in there too that we've learned as we go across. But I wanted to bring up the third power because they like to bring up the third power in this section. Okay, so that's just a little bit of help with end behavior and turning points. If you need help with degree, there is a video already in the